In this set of videos, we're going to go through hypothesis testing, how it actually works. And there's going to be 3 separate example videos where we talk about what is different and particularly, how to use the calculator to get at the p-value, which is really the important piece of this information. The p-value method for hypothesis testing is going to be the same for all 3, right? We're going to state our null hypothesis. Remember, that is that the mu is some particular value given mu naught. The alternative hypothesis. The alternative hypothesis is that the true value is less than. That's going to be a left-tailed test. It's going to be greater than. That's going to be a right-tailed test. Or it's simply going to not be, right? And that's going to be a 2-tailed test. Okay? We're going to have some level of significance alpha, and that's going to be the boundary upon which we're going to compare our p-value, right? Given our test statistic or test data, we're going to compute our p-value, and we'll use the p-value compared to the alpha value to determine whether or not to reject our null hypothesis. If the p-value is smaller than the alpha, then we will reject the null hypothesis. If the p-value is larger than alpha, we will fail to reject the null hypothesis. Right? We never accept the null hypothesis. And then, probably most important at the end, is we want to state a conclusion based on our findings that is reasonable given the conclusions that we have made. All right, we call the value alpha the level of significance. If our p-value is smaller than alpha, then we say that the data is significant at this alpha level. Right? This is what the level of significance means, right? So if the p-value is smaller than alpha, the data is significant. If the p-value is larger than alpha, then the data is not significant. For example, let's say we use an alpha of 0.05. Remember, that was the thing we had used for unusual before. If our probability was less than that, then the data was unusual. If it was greater than that, then it was not unusual. So alpha of 0.05 is actually pretty common in the literature. Right? So alpha 0.05 is our level of significance. And if the data we collect has a p-value of, say, 0.022, right, so p is going to be less than alpha, then that means we're going to reject the null hypothesis, accept the alternative hypothesis, and that means our calculation shows that the data is statistically significant at the alpha 0.05 level. And now let's go through 3 examples, one for each type that we're going to see a little later on, based on whether or not we know the population standard deviation, we only know the sample standard deviation, or whether or not we're looking at proportions.